Okay, it was a long trip to be here, but hopefully I will be awake to present. So, my name is Salama Ashoush. Actually, I'm a software engineer. My official title at Box is Senior Software Engineer. Box is a company for cloud storage and a lot of extra service on top of the storage. And yeah, as Basilica said, I don't only do front end, but sometimes I do also a lot of experiments, a lot of stuff, and like to learn a new stuff. So just a disclaimer, I'm not gonna fight about frameworks because I will mention a lot of frameworks and I love all of them the same. So there's no fight about frameworks. So yeah, the topic of today it will be about reactivity and specifically we will start widely talk about reactivity in general, but then we will narrow it to talk about signals specifically. So first question, what is reactivity? There are a lot of definitions about reactivity, and in general, I like this one because it's like declaratively it's expressed in the relationship between values over time. So, and this one is coming from Ryan Carniato. Have you ever heard about Ryan Carniato?
It's Isabel.
No, it's a creator of Solid.js, and
Yeah,
who
from
like we call him the father of signals. So because he's the one who advocates signals until it's adopted in a lot of frameworks later on. So to explain what I said, so imagine that we have a C, this equation, C equal A plus B, right? And our job with reactivity is to keep it maintained, right? To keep it always evaluated in the right time and not over calculate stuff. So as we will see later. So there are different kind of reactivity. Mainly there are two kind of reactivities. One of them is coarse grain reactivity, and this probably you already using. How many people use React? How many people use Vue? So it's probably you already use coarse grain of reactivity because it's like the implementation of React. It's funny enough, people sometimes say React is reactive, but it's not in a mechanical way. So we will learn later. So this type of reactivity is like when you have an update, you basically need to recalculate a long tree, a really big tree to come to the update the small base that you want. But you cannot directly update it. That's why it's called coarse grain reactivity, because you have to recalculate a lot of stuff to figure out which part needs to be updated, right? And there are another type of reactivity which is called fine grained reactivity, where you know directly where to update the value, right? Imagine that you have a value somewhere and you have a DOM element somewhere else. When this value updates, you just go directly to this DOM element to update it. So unlike React, for example, you have to first recalculate all the component tree again and then do the diving algorithm and then decide which DOM elements need to be updated. So and this kind of activity is already implemented, funny enough, on almost all the frameworks except React. So Solid.js, Svelte, Quick, Angular, and Vue currently already have also. Just then two notes about Angular and Vue. Recently, Angular version 17 has found activity with signals. Vue has it's not released yet, but they are working in something called Vapor mode, which is basically same as Solid.js as we will know in a bit. So, like, what defines a reactive system? Like, if you have a system, when to call it reactive or not, right? There are some components of a reactive system. One of them is you need to have a unit, right? And this unit, the name of it, differ between implementations. For example, in some frameworks call it wrapper, holder, subject, signal, whatever. It's the same concept. It's a reactive unit. And then you have reactions or effects, watches, auto-run subscriptions on these values, right? And then you have derivations or computation or like computed tank memos, as you call it, it's the same thing. But on all of the system, you must have the three components, the three parts, right? And there are some other mechanical stuff under the hood. You don't interact with them directly, but they are always there. Like, for example, what kind of algorithm this reactive system is working on? Like, it's push-pull, hybrid, or what? And scheduler, does it do concurrent mode or not? And dependency tracking, is it manually, like use effect? You need to put the array of dependency in there. or like is it automatic in some other framework. So, and there are also, you can compare them is a runtime system or compile time system. Runtime system, like for example, one big example is this RxJS. If you worked with Angular before, for sure you will know what RxJS is. And let's say you have this same equation as before, you have two variables and you need to maintain the relationship between these two variables in another computation like C. So in RxJS, you do it like this. You have the unit is subject or behavioral subject in this case. So you declare two reactive units. And then basically the computation or like the derivation is a bunch of operators on this system. So you have like combine latest and then you pipe it to, at the end you basically do the thing. What we need is plus them together. And then this system is lazy because nothing will happen until you subscribe. So if you work with RxJS, you know this thing. And then basically when you push, C will get notified and then the equation will run. So this kind of system is all happening at runtime. So there is no magic. This is what is happening. This is what you write and this is what you get, right? Compared to, for example, to signals, let's say this is not a specific library, it's just imaginary one. So you have basically two wrappers again, but now we call it signal. And then you can, based on the implementations, this is how you do derived values, right? There are two kinds of derived values in this case, like there are just a derivation, like you have two values and then you combine them together. Like in this case, it's like just a getter or func. And then there are actually actual memoization, like it will not run again until you like some dependency change, right? So they're kind of the same, but the difference is one is have cache and the other one doesn't have cache. And then the effect with this, like the second, third component we have is just when this effect is basically all the system that ties all the system together. Like you can have units, and then once you have subscription effect auto run or whatever, then magic starts to happen, right? If you have an effect and then you update the value, this effect will run again. We will implement our own signal framework in a bit, right? This is all runtime, right? But there is another kind of reactivity which is actually happening in compile time, which is like magic. So if you use Svelte, so basically you write regular JavaScript until you come to this part, which is still regular JavaScript, but it has a special meaning, right? This thing is label, like if you know JavaScript, you know this is like a label statement. But in this case, it's actually not actually as a label statement. This get compiled to something completely different. And this will be compiled to the code is not there, it's just it will be compiled to a code that maintains the same relationship. It does the manual update for us. It's fine-grained, but it's happening in compile time. So this is not the code that actually run in the browser. This is the code that got compiled to another lower level code that actually run. So this is really important statement. Like change detection is not always same as reactive or reactivity, right? Because reactive, when you do stuff, it does change stuff. Like it does, you see the value changing, you see stuff happening in the screen, right? Angular JS before it was also like change detection with there. When you do something, stuff happening, but it's not actually doesn't mean it's a reactive system, right? Because change detection can happen by any way. You could manually do it behind the scene. You could do it like with a really fancy algorithm, debugging algorithm like React. Like they have really complicated consignor that does debugging and stuff. You could do it like dirty batching for the DOM element like Angular JS all to one. Or you could have a reactive system as we saw in as a runtime or compile time. So as I said, like you could do change detection in many ways, but one of them is reactivity, right? And this is what we will talk about today. So we'll talk specifically about signals, and signals concept is really simple, right? You have a value or a wrapper. When it's updated, notify computed value or effects, right? And then everything, like if you have a fully reactive framework and like Solid, everything just follows the same thing, like it's the same flow. And it's really simple and declarative and composable, right? I will go quickly to some history where where Signal started and what we have now. So it's actually Signal nowadays really trendy, but it's not a new concept, right? It's been there for a long time. Like, have you ever heard about Knockout.js? Yeah, like if you really been there for a while, you will for sure know Knockout.js. And it was reactive system, right? You have observables and you have computed values and you have effects, right? And then it's basically it would work really well until there are some leaking or some downside that we will talk about it later. So, and then there's like AngularJS came into the picture, and then it was like, wow, HTML, and then you could just put ng model in the HTML element, and then suddenly I have two-way binding, and then it's like magic, right? Until you come in a complex situation where you really you don't know what is updating the value, and you don't know what is going on, and it's really a foot gun or a glitch. How many people spent hours debugging asynchronous actions in AngularJS? Right. And then React came into the picture, and then they introduced a really good concept, which is like the state or set state. They said, like, let's stop all this two-way binding thing, and let's start from one way, like one source of truth for the value. And they say, you have a value, we have equation, right? A state equal UI, right? Like, let's say F takes the state and then equal UI, right? And this value, this computation is still maintained until today. So, and basically what it means is basically when you need to debug something, you just need to debug what are the state changes that you made. You don't need to care about how the UI got updated because this is what React takes care of, right? But you need to only debug and take care of like how your state got updated, how this value came to this like number or whatever, right? And it's really simple, right? And this like, and they also introduced something called like read-write segregation because you have like separate value for reading and another value for writing to like the state and the state setter or like how you call it. So, and they also have VDOM and all the stuff that React already have today, right? And as I said, they introduce really strict data flow, right? You can never update any value until you update some state somewhere, right? If you do something else, you're doing React wrong, right? And you end up with a lot of issues. And people will know it for sure when you need to, for example, if you use jQuery with React, for example, or you know how it works. So, and then there are a lot of adoption of React. Like React is really massively adopted everywhere. Like it comes from Facebook. Facebook is really like ginormous application and it's really big company. So there must be really good framework. And people started using it because we had like the competition back then was like AngularJS, Knockout, and they all have like glitches and stuff. And that's why React is still dominant today because it was really good idea, and it's still a good idea, but there are some downsides that we will know. And then we have Mopex, which is kind of reactive system, but focusing on the store value doesn't do UI stuff. And it was like push-pull system, hybrid system, like you do state update, like when you update the value, but they also sometimes go on the graph and check if there are some dependencies that also need to be notified. So this is what's meant by push-pull reactive system, right? And then there was like fine-grained reactivity was already there, right? For a while, Knockout.js, Mopex, but there was like, as I said before, this observer pattern, like when you have like a value and then you do some subscriptions to it, and then this subscription need to be manually cleaned, like in RxJS, you need to unsubscribe, otherwise you end up with a lot of memory leak. And there was basically a lot of memory issues and a lot of like uh, like foot guns as well. Like sometimes you also was really confusing to know where stuff are coming from, especially with observable streams and stuff like this. And then there was a library that nobody knows about. It's called SGS, and then it's like actually introduced a concept coming from electronics, like in a circuit board, you have a concept of signal, right? And they introduce the same thing. Like, basically, you have a data and you have an effect or drive the stuff, and you automatically take care of dependencies and everything for you. So you don't have to manually unsubscribe or do anything, right? And it's basically like you have a root, as we explained it before, and then this reactive route takes care of the subscription fee. So, and it's also introduced, this is what is the root thing I explained, reactive ownership, right? Because there is somewhere where it all started, like the reactive route. You, by the way, have a reactive system since the beginning, but it's the UI part. The UI part is not the reactive part, like because they still use VDOM, which is still do the same as React, but the refs and all the stuff, it's a fully reactive system, fine-grained reactivity. But the way they update the UI is not the reactive part. So, and that's why they are working in vapor mode, which is basically will get rid of VDOM, and then you end up with a fine-grained reactive framework totally. So that's why Vue until today is not a fully fine-grained reactive framework. So, and they built the reactive system, and then they did a lot of optimization for VDOM to make it work. And yeah, that's why when you say Vue is VDOM, is same as React, but it's actually not the same because they do a lot of other optimization since they have templates, not JSF. And then we have SolidJS, which is like a kind of a fully reactive framework, and it would be like mostly the focus of the demo and the code in the other slides. So basically, you have this is how you write the code. You have a signal, and you have read and write is coming from React, like read and write segregation, and then you have like a callback or just a function, right? And then whenever you need to read the value, you just say call the getter, right? Whenever you need to write to the value, you just say sit in the value. One more. Sit in the value like in the line 20, you say it like 3. And then when this is being called, basically we go to the effect, and it looks somewhere if there are some subscription, and then it run all of them again, and so on. We will implement this kind of system in a bit. How I'm doing with time. So yeah, so now we have you heard about Quick? Yeah, Quick is like also another hyper fine-grained reactive framework, because they also do like some tricks. They're not fully fine-grained reactivity, but basically they follow what SolidJS does, but in a React way, right? Because they use the same thing. They have used signals, which is kind of like SolidJS signals, but they also like if you look in there, like this thing, like if you read like if you, for example, do this equation, right? In SolidJS, something like line 13 will not work, right? Because there is like because components in SolidJS run only once, right? And then when you run it first time, you get the value and it's fine. But later when you change it, it will not update this part. Like if I go back, like let's say, if I do this but I remove the function in there, it will not update it, as we will you will try it in the background and you will say it's not updating. But why it's not updating? Because this is basically regular JavaScript, right? This signal need to be called to maintain the subscription, right? The read thing need to be called somewhere, right? It's called once, and then if you the component run only once, and it didn't run again, then it will not do a new subscription, right? Because that's why we need always to wrap it in there. But in Quake, they do a trick. Yeah, let's say when you have sorry, I go back. So when you have something like this, if we can make it reactive for you. But then if you don't do like a function, we basically do like React does, rerun the full component again, right? And this is like why I call it hyper, because it's fine grained until you don't need until you do something else, right? And then it's not fine grained again. So they have basically the same thing. You have effect, is called it usable visible task, and they have computed, which is the same three. Like if you look on all the frameworks, we have always the same concept, different names, but it's always the same. And the Quick has extra thing, which is called resumability, which is a really big topic. I'm not gonna discuss it, but basically start rendering the stuff in the server and then you stop, go to the client, continue to work. So it's different than hydration, because hydration need to start on the server, go to the client, restart all over again, doing the same work until you have the state that maintain the law. And Quick, they do it in a bit differently, but yeah, it's not our topic today. So let's look under the hood how these signals work, like how we can implement our own signal. So let's say this is create signal function. Let's say it's function that takes a value, right? And then we basically have a read function that returns the value, and we have a write function that basically set the value, right? And then we return both of them, right? And then we start using it, right? We have count and set count, right? And we start doing the stuff, but still it's not updating, right? Because there's no magic, right? But then how to actually be reactive? Because you need to call line by line. If you run this, there's no automatic updating to the value yet, right? So basically we have the wrapper or the value, the unit. We need to implement the effect to make the system work, right? So the reactive system will never work with only signal. It will always be an effect system. And this is how we can implement the simplest effect system. So basically to create signal, maintain a subscription array in it, or a subscription set, right? And then basically on reading, we have a global context in first line. We have a global value. It's root thing. Now it's a global because we make it simpler. And then we basically say, yeah, when I read the value, I look at this stack and get the last thing that was put in there, right? And then I run it. If I found something in there, I immediately call it. I subscribe to it, and then I return my value. And when this important thing is what makes the relationship work, right? Because basically I have this subscribe thing, and which is a function I added in there. It's basically will add this thing I got from the stack to my internal subscriptions, right? And then we'll also add the subscription to dependencies of this thing I got, right? To maintain the relationship. We will know why we need to add these dependencies for later, but and then when I do the right thing, basically I set the value and then I look for every subscription, because let's imagine you have set A, like you have an A and then you have set A and then you have create signal, right? When you read it, you basically already added an effect in the stack, right? And then when you write to the value, it will take all the subscriptions we have and then call them, which is actually just a function. So this is basically, it's immediately executing the effect we have, and then we return read and write. So let's ignore this part for now, and we'll come back to it. So, but now if you have the same thing, count and set count, and we create the signal. If you remember correctly, when we call count, like in this, where is it? Like this slide, if you call this create effect, it's actually a function. It takes this function, and then we will look at the create effect. And then this counting, when it runs, that's why it's a function. When it runs, it will look in the global stack thing and then takes whatever in there and then add it to its own subscription. And then when we write it, it will take all the subscription we collected during the execution and then run all of them. And this is basically why we need the third thing, which is create effect. Basically, create effect takes a function, as we saw, and immediately execute it, like in there. This is just a wrapper inside, and it will immediately execute it, and then it will remove itself from the stack, right? So this cleanup thing, it's needed because we need to do something called dynamic dependency tracking. But basically what we have in there, we have execute function, and then we create this object which has execute and it has dependencies. If you remember the signal, when you read, it pushes something to dependencies, and this is what the dependency set there. Basically, it pushes itself in there, and then when you create the effect, it immediately executes the function, and this function do a cleanup, which basically remove all the dependencies from all the signals, and then it pushes itself again, and then when you read again to a signal, it do the same thing, and this is how the reactive system works. Is it difficult? See some people sleeping, but let's move on. So this is basically how it's working under the hood. So, and basically, if I ask you now, how we do compute like memo, like or computed values? You need in computed values. Basically, you need a value, and then when something updates, you need to reevaluate the thing, right? And if you think about it, we have now two things, like we have a value, which is signal, and we have effect, right? Can we combine them to make the memoization? It's basically, it's literally like this, like because the memo thing is basically a signal that has an effect in it. This how does it work? Because the effect thing executes itself immediately, and then when we set the value in there, it looks dependencies and it runs all the subscriptions for the signal, and then it will trigger the effect again, and so on. So that's why when you have this something in this function, because memo usually you have a, let's see if I have a example in there, and yeah, I have this example. So basically, a memo is like this function will run, and this function has signals inside of it. If you remember, do you know React use effect?
Yeah.
You know, you always need to put some stuff in dependencies array, right? If you did it wrong, then something is not updating, something is over updating, some stuff is not running correctly. And this system, we don't need to take care of dependencies manually, because it's basically all done by signals. Since the fact that signal is a function that execute, and inside of it there are some logic that maintains the dependencies automatically for us. So that's why, for example, if you have this display name and you have a flag to show full name or not, if you do it in React, first name and last name will always be evaluated, right? Because it's just one effect that has two dependencies, first name and last name, right? And whenever one of them change, it will evaluate the computed value, right? Display name will be reevaluated. But in this system, it will not. It will only, if this show full name is true, it will only evaluate first name. If it's false, it will only evaluate first name. No matter, like if you see last name is there, but it will not evaluate it because it will never run, right? It never pushes itself to the stack, right? Because if you remember, we have this cleanup function that basically remove the stuff from all the effects, and then whenever you run a signal again, it pushes itself again, and it do the trick again, right? That's why it's called dynamic dependency tracking, because basically if you have flags like this in React, it will never work because it's always evaluate, no matter if one dependency is two dependencies, all of them, it doesn't matter. It will always evaluate the full thing. See what we explained, but doing it dynamic tracking again. Yeah. So basically, if you look at this stuff we explained, we have three stuff: effects and signal and computed values, right? But we can do a lot of stuff, lot more stuff. Like if you use Solid.js, for example, you don't do actually this small pieces individually. So you can, for example, use something called create store, which basically takes all this value and make it individual signal for you. So you don't have to do it manually. So you can do like nice declarative stuff still, but you have a still fine-grained reactive system, right? So for example, in this case, if I update only the age, it will only update the page that uses the age. It will not update the full object in this case, right? And this is the same example in Quick, but it's the same concept. It's like still, this is actually doing two things. It's doing signals, but it's doing it via proxy. Like they create a proxy for the object, and when you access the key, they basically have a underneath the hood, they have a signal thing. That thing we explained. And there is like if you work with asynchronous stuff, like in React, most of the time you use Redux or use React query or tiny stack query, if you heard about it. But basically there is like, if you need to fetch asynchronous stuff, there is this create resource, which basically fetch stuff, and then you have to miss it, like either refetch it or mutate it. It's basically keep track of asynchronous stuff. It's the same idea. It's the same idea in Quick. I just wanted to show different example and different Quick to just say, it's just, if you understand the concept, you can do it in everywhere. It's not a new thing. Yeah, so it's basically the same thing. So this is what I explained before. Like if you have this thing now, double count, in SolidJS, it will not be reactive, but you need to wrap it in a getter to make it reactive. And I explained why, because it's the component itself is actually not something special. It's just how you organize your code. You basically can write this thing anyway. You can make one component or your entire app in one component, and it will still be fine-grained reactivity. You know, in React, when you have a lot of re-rendering issue, you end up splitting your app, right? You need to make smaller components to be able to debug where a value got updated, and also to avoid re-rendering unnecessary stuff. But in Solid, this component is just a organization thing, right? And it run once, and then everything else there is they have a compiler that basically takes the DOM and put it in an effect. And then if you have signals running inside an effect, you know the trick now. You know how we implemented it. So it's basically how it's maintained, even for updating the UI. So it's not tied to Adobe. That's why basically you can take all of this and make it a global state if you want. So you can basically, yeah, this is still the same example, but I said in Kuwait they do a trick to make it run. Yeah, so one good thing. So basically, if you need to make a global state now in SolidJS, you can take all of this stuff and put them in a file and then import them everywhere. You don't do any special thing, because signals and reactive system is not tied to UI. In React, it's tied to the UI. You cannot do state outside of UI, right? You always need to use this hook inside a component somewhere. No matter how you hide it, it must render inside the component, because the full system is based on virtual DOM and diving, and the algorithm, it works in this way. But in reactive frameworks, basically, if you need to make a global state, then you just move it in a file and start using it. It's just organization matter. So I'm almost done. So for example, there are some attempts to make React fine-grained reactivity, but it's not always recommended. There is something called React signals. If you heard about React, it's like a smaller React, but they have an implementation of signals. But keep in mind, it's fine-grained reactivity on its own, but inside the component is still not fine-grained, because you're tied to the system, and the rendering system in this case is not fine-grained rendering system. And this is actually something from Dan and Promov. He recommends not to use this thing because it was using some internals of React, and then it ended up for people reporting a lot of bugs for React, but it's actually not a bug in React, but it's just in the case. So it's not recommended to use the signals in there. But there are some atoms, some other frameworks which have similar concept. But yeah, so for example, this also, like in Svelte version 5, they have concept called rules, and now it's actually Svelte was always fine-grained reactivity, but it was not signal-based, right? In version 5, it will literally be signal-based, and you can see it like state and drive and effect, the same three concept we had from before. This is Angular today. So you have a signal, and then you can update the stuff, and then you could use it in the template and stuff. And it's also like 3 months ago or 4 months ago, it was not fine-grained reactivity because we had this Zone.js and we have the system for rendering components. But then they released version 17, which also introduced signal component. which now you can use without Zone.js. So which is fine-grained, fully the system on its own is fine-grained reactivity. So I don't need to explain the stuff. I explained it again. Basically, you have a lot of wrappers. For example, Vue, children, all the stuff that you used to do in Angular, they have a wrapper for it, which is like use signals under the hood. Do you know what language is it?
Rust.
Yeah, who write that?
I recognize I don't write Rust.
Yeah, it's right. It's also signals, right? You have to create signals and stuff. This a framework called Leptos, which is like inspired by SolidJS, and it uses WebAssembly to render the DOM and do the stuff. But it's basically have a fine-grained activity with signals. So signals is not a JavaScript thing. It's universal thing. You could use it in any language if you want, if you know how to implement a good one. But now, hopefully, you know, because you got some basic stuff. So this last thing I would like to say is the signal is just in the new VDOM, because when virtual DOM was introduced, there was a lot of people, what the hell is this? Like, why do we need to do this state thingy? And why do you need to write JavaScript with HTML and stuff? So there was a lot of like debates about if it's a good idea or not. Same happening now with signals, right? And it turns out it's a really good idea because all the mainstream frameworks already adopted it, except React, and they kind of have their own response to it, which is React compiler thing. But it's still, the system is still the same, but they have compilers that can detect stuff and make re-render less. But anyway, it's this is what I wanted to say. So,